We're going to work on 4.2 today, but there's a lot of 4.2 we're not going to do. We're just going to do kind of the first half of it. So, there's a review in the book of what we did last time. How would you simplify a to the negative 2? What does a negative exponent do? It's going to reciprocate the base. So right now the base is a over 1 raised to the negative 2. I flip the base, which would be 1 over a, and then the exponent changes to a positive. A negative exponent flips the base, and when you do that flip, the exponent becomes positive. So this would be 1 over a to the second. So in word form, that would be the negative exponent one. Right? That's we performed a negative exponent transformation. Okay? A times b all raised to the 4th. Can you simplify that? It would be 4 copies of AB. So AB times AB times AB times AB. When I put all those together, what do I get? I started with AB to the 4th, but separately they would be A to the 4th, B to the 4th. So this is A to the 4th, B to the 4th. Yep, that would be power of a product. All right. C. What is A to the 3rd to the 4th? Well, let's think about it. What does the 4th power mean? You write it 4 times in multiplication form. What does 3rd power mean? So the inside one, the a to the 3rd, is actually a, which we condense into a to the 3rd. It says we want 4 copies of this. Does that make sense? So what would 4 copies of this look like? A to the 3rd, A to the 3rd, A to the 3rd, and A to the 3rd. We would write that A to the 3rd 4 times. And now what do I do with all those 3's? Add them all together, and I get 12. So this would be A to the 12th. That's raising a power to a power. Now what's the shortcut? Multiply the 3 and the 4 together. Okay, and so that's really important. If I have, look at C, A to the 3rd times A to the 4th, that is A to the 7th. Because the first one has 3 A's, and the second one has 4 A's, and it's all multiplication. 3 A's times 4 A, or sorry, A to the 3rd times A to the 4th is A to the 7th, because if I count them up, I would get 1, 2, 3 here, 4, 5, 6, 7, A to the 7th. No, C is a power raised to a power. So this is the power of a product. What? Let me look at the choices. I can't see them. That would be power of a product. Yes. Power of a product. Okay? Does everybody understand the difference? If you're multiplying bases, you add the exponents, like this one. If you have an exponent raised to an exponent, you multiply the exponents. And if you ever forget, just write it out. This one you would write out 7 A's. And this one you would write out 4 copies of A to the 3rd. And then you just count up the A's and you'd end up with 12. All right? All right, E. A over B to the 3rd. That is similar to what we did here, except it's a divide instead of a multiply. So it would be A to the 3rd over B to the 3rd. That's the power of a quotient. Yep. All right, what about F? Oh, no, wait, sorry, that should be, no, that's, yeah, so that was power of a quotient. The next one, if I have a to the 6th on top and a squared on bottom, how do I simplify that? You would subtract the 2 from the 6. And if you forget, you can just write your 6 a's on top and then your 2 a's on bottom, and you cancel, and you end up with 4 on top. Nope. A to the 4th over a to the 0, which is just 1. So it's just a to the 4th, because both of those a's went away. Okay? You could also write it, what if I subtracted the wrong way? What if I did 2 minus 6? Then I get 1 over a to the negative 4, which is the same thing, because that negative just tells you to flip the 1 over a upside down. Okay? We always want to end with positive exponents. So this would be considered not simplified. Mm-hmm. Yeah. Yep. And it's just like if I had 6 over 8, I wouldn't leave it in that form. I'd simplify it to 3/4. We would never leave a negative exponent in our answer. We would always just move it to the top and then change it to a positive 4. Well, yes, but the real reason is we want to make sure everybody ends up with the same, not only the same answer, but the same look of the answer. So there are an infinite number of ways to write 6 over 8. Right? You could do 3/4. You could do 30 over 40. You could do 300 over 400. And so we want everybody to end up with the same version of the correct answer. So we simplify things for that reason, and because the simplified version is usually easier to work with than the non-simplified version. Okay, and then a to the 0 is 1. Why is it 1? Not because there's 1a, because everything canceled. You guys understand the subtraction rule, right? So what if I had a to the 3rd over a to the 3rd? The subtraction rule tells us, bump this up, and we get a to the negative 3. What is a to the 3rd times a to the negative 3? That would be a to the 0, right? But if I looked at it a different way, a to the 3rd over a to the 3rd, if I cancel all the a's, what's left? 1 over 1. So one way when I solved it, I got 1, and the other way when I solved it, I got a to the 0, which means a to the 0 and 1 must be the same number. I and the square root of negative 1. Yeah, I and the square root of negative 1 are the same. I squared and negative 1 are the same. Yeah. Okay. So we are going to work today on raising exponents to exponents. So if I had x to the 5th and I raise that to the 3rd, what would I get? I would get x to the 15th. Because I have 3 copies of x to the 5th. So x to the 5th times x to the 5th times x to the 5th. I count up all the x's. 5, 10, 15. Okay, that's pretty easy. What if I did this? Y squared to the negative 3. Now, you can either flip it now, or you can flip it later. It doesn't matter. So let's multiply these together, and I get y to the negative 6. Flip it upside down. 1 over y to the 6. That's the answer. What if I flipped it first? What would this look like upside down? 1 over y squared. And I'm going to raise that to the 3rd or the negative 3rd? The 3rd. The negative went away when I flipped it upside down. So now it moved. The 2 was positive, right? So let me show you a different one. Hold on to that for a second. I'll show you a different one. So now this is a 3. So now I need to multiply these together, and I get 1 over y to the 6th. Okay? Now, McCrae has a really good question. Why didn't the 2 change? Well, because I can only get rid of one negative at a time. So let's say I had a to the negative 3 and a to the negative 4. Which one do I have to get rid of first? It doesn't matter. I could put 1 over a to the 3rd, and then this number would be negative 4. Or I could do 1 over a to the negative 3, and this number would be positive 4. Yep. This one needs, or sorry, wrong one. This needs to be flipped again. So it would be a to the 3rd to the 4th. And then this one needs to flip, which would be a to the 3rd to the 4th. And what do you notice? They're the same. You're going to get a to the 12th. Right. Every flip will get rid of one negative. And it doesn't matter what order you flip them in. You can flip from the outside or flip from the inside. It doesn't matter. So what you have to be careful of is like that last problem we did. So if I had, say, 3 to the 3rd to the negative 2, if I flip, I change this. Don't write that with a positive 2. That would be wrong. Because the flip changes this, not this. Or it can, but it can only change one of them, not both of them. Okay? All right, what if I had a squared over b to the 3rd to the negative 2? Do I flip both of them? Yes, they're both underneath the negative. So I flip them both. B to the 3rd over a squared raised to the 2nd. Good. Now what? I bring this in. Ooh, nope, because I have 2 copies of b to the 3rd. So it's b to the 3rd and b to the 3rd, which makes b to the 6th over a to the 4th. So in order to add, we would have to have b to the 3rd times b squared. That's where you would get 5. If you multiply bases, you add exponents. If you raise a power to a power, you multiply exponents. Got that? Well, in this case, they're different. So I have b's and a's, I can't simplify. But if it was b to the 6th over a to the 4th, or sorry, b to the 4th, then you could subtract them. Yeah. But let's try that. So let's do b to the 6th over b to the 4th, all to the negative 3. So I could flip b to the 4th over b to the 6th raised to the 3rd, which is equal to b to the 12th over b to the 18th. And then I subtract. Where is my answer going to land? On the bottom. How many on the bottom? So I would either get negative 6 on top, and then I'd have to flip it, or I get positive 6 on bottom, and I'm done. So 1 over b to the 6. Now that's not what I would do. Is there an easier way to solve this? You could do that. So we simplified as the final step. What if we simplified as the first step? What is b to the 6th over b to the 4th? B squared. Or no, not squared. Sorry. Oh, this is... Wait a minute. Okay. So, yeah, that's b squared. That's right. So b to the 6th over b to the 4th simplifies to be b squared. So 1 over b squared to the 3rd, which is this. So you can either simplify at the beginning or you can simplify at the end. It doesn't matter. Sometimes You can't simplify at the beginning, but you can at the end, depending on what the problem is. That might happen. But I would recommend that you simplify at the beginning if that's a possibility. Sometimes it's not. Okay. So now let's work into Okay. So let's do, on that same page, look at 199. There's some sample problems we're going to do. This is 199. You don't need to write these down. Look at A. 5 to the 2/3 times 5 to the 4/3. If the bases are the same and I multiply, what do I do with the exponents? Add them. So what is 2/3 times, or plus 4/3? 6/3. So I get 5 to the 6/3, and 6/3 is really just 2/1. 6/3. So 6/3 is 2. 5 squared is 25. Okay. Look at B. 3 to the 1/5 times 3 to the 4/5. The bases are the same, so I add the exponents. What is 1/5 plus 4/5? 5/5, which is 1. So 3 to the first, well, let me write it out. So it's going to be 3 to the 5/5, which is 3 to the first, which is 3. So the answer to B is just 3. No. No, because if I had x squared times x to the third, it's still just x to the fifth. I just count up the multiplications by addition. Yep, the base does not change. That's a good question. The base does not change. Just the exponents change. Okay, C. 4 to the 2/3 times 3. I multiply 2/3 and 3. What is 2/3 times 3? So 2/3 times 3, which would be over 1. I just multiply straight across. 6/3, which is 2. And 4 squared would be 16. Straight across, not cross multiply. Multiply straight across. Yeah, don't cross multiply. Okay, 10. Or sorry, D. 10 to the 1/2 times 4. That'd be 1/2 times 4, which is 2. And 10 squared would be 100. All right, turn the page. Oh, no, wait, let's do E. Sorry, we need to do E. 8 to the 5/2 divided by 8 to the 1/2. And then, so you'd end up subtracting the 1/2, right? So it would be 5/2 minus 1/2, which is 4/2, which simplifies to be 2. And 8 squared, 64. So let me write that out. We would get 8, not x. We would get 8 to the 4/2, which is 8 squared, which is 64. Mm-hmm. What's that? No, because this 8, when I subtracted it, when I moved it to the top and it became negative, there was a 1 on the bottom. So what we did was 8 to the 5/2 times 8 to the negative 1/2, and then the 8 on the bottom moved to the top. And then we just do 5/2 minus 1/2, which is 2. Good question. All right, now we can turn the page. Yes, so we're going to do the same thing now, except they're not going to simplify as well as they used to. So let's do, what is 7 to the 1/4 times 7 to the 1/2? So the bases are the same. I add the exponents. What is 1/4 plus 1/2? Some of you can do that in your head. It's 3/4. What if you can't do it in your head? Use your calculator. 1/4 plus 1/2, and that gives me a decimal, and then I just push math, fraction, and I get 3/4. So this is 7 to the 3/4. Okay. Just as a review, what would that be in radical form? Would be what root would it be? The 4th root of 7 raised to the 3rd. Do you remember that conversion that we did the other day? This one becomes the root, and this one becomes the exponent. But you don't need to do that. That's just a review. Okay, today you don't need to worry about that. You just need to simplify. Okay. We'll get there in a minute. Hang on. So what about 6 to the 1/2 times 4 to the 1/3 squared? Can I combine the 6 and the 4? If I had x squared and y to the 3rd, can I combine those? So if I had x squared and y to the 3rd, can I put those together? No, because the bases are different. Okay, if the exponents were the same, if I had x squared times y squared, I could say x times y to the 2nd. So we need to understand that the 6 and the 4 don't go together because they're different numbers, so they don't mix, and the exponents are different, so we can't group them in the same exponent. If they both have the same exponent, then we can combine them together and just use a single exponent. But neither of those happen in this case. So what we need to do is change these according to the 2. So what do I do when I raise an exponent to an exponent? You multiply. So it would be 6 to the 1/2 times 2. What is 1/2 times 2? 1. So I get 6 to the 1st times 4. What is 1/3 times 2? 2, nope, it's 1/3 times 2 over 1. So 2/3. And that's the answer. Okay. Now there is a decimal answer, but we don't care what it is today. Okay, all we're doing is getting the numerical answer, the exact answer. Okay. What about this? 4 to the 5th times 3 to the 5th to the negative 1/5. I need to flip it. So I put 1 over, what do I get when I flip it? 4 to the 5th. Should it be a negative 5? No, because I am getting rid of this negative, and you can only get rid of one at a time. So 1 over 4 to the 5th times 3 to the 5th raised to the 1/5. Is everybody okay with that? So now I need to bring this in. What is 5 times 1/5? So 1 over 4. What is 1/5 times 5? 1. So I get 3 to the 1st. Does that simplify any further? I get 1 over 12. That's the answer. In that case, all of the exponents simplified out. Okay. What about this? 5 over 5 to the 1/3. What exponent is right here? A 1. The bases are the same. What happens when I have the same base on top that I have on bottom? They do, using subtraction. So I need to move this one up, and it becomes 5 to the negative 1/3. And then what do I do with those? 1 minus 1/3. What is 1 minus 1/3? So if I have a whole and I subtract a third, how much do I have left? 2/3. So this would be 5 to the 2/3. And that doesn't simplify any further. Okay, let's see if that's going to be enough. Um, um, product of radicals. Do I want to get into product of radicals? I don't think I do. Okay. So we're actually just going to do... Oh, man. Yeah, we've got to do some radicals. Okay. All right, look on page... We'll do the easy ones, but not the hard ones. All right. Look on page 201 and example 2. The third root of 12 times the third root of 18. The radicals are the same, so I multiply the 12 and the 18. 12 times 18 gives me 216. How do I simplify a cubed root? We factor it down, and we're looking for groups of 3. So what goes into 216? Oh, I know. 12 and 18 do. 12 and 18, 6 and 2, 3 and 6, 2 and 3, 3 and 2. So we get rid of all of this stuff. What am I looking for? Triplets. Do I have any triplets? A triplet of 2s and a triplet of 3s. So I bring out 1, 2 and 1, 3. What do I do with those? Multiply them. So on the outside, I get 6. And what's left on the inside? Nope. I got rid of all the 3s, and I got rid of all the 2s. There's nothing left. So I'm done. So it's 1, but it's just 6. Yes, that's a good point. You could have factored them at the beginning, not created the 216. That's a good point. As long as these match, yes. Yeah. You would just pretend that they're the same number. Yeah. Separately, they don't simplify, right? So 12 would be 2 times 2 times 3. Can I pull anything out? No. But when I combine that with 3 times 3 times 2, now all of a sudden I have enough. So we just pretend that they're together. Okay. All right, what about this one? The fourth root of 80 over... Oh, sorry, the fraction's on the inside. Over 5. Should I factor these separately and then simplify, or should I simplify and then factor? Let's definitely simplify. So how many times does 5 go into 80? 16. So I get the fourth root of 16. What is 16 made up of? 4 2's. If you're adding, it's 4 4's, but if you're multiplying, it's 4 2's. Can I bring anything out? One set of 2's, what's left? No, I took them all out. So I bring all of these to the front, and they're represented by a single 2, and nothing is left over, so the answer is just 2. Okay. What about this? The third root of 135. What do we know goes into 135? 5, and I don't even know what that is. 27. What is 27 made up of? 3 3 3. What am I looking for? Triplets. Do I have a triplet? So I write 3 on the outside. What's left? The third root of 5. Yeah. Yeah, it's going to get a little bit harder, though. So, yeah, we're not going to do that one. That one's too hard. We're not going to do that one. Okay. Let's do the third root of 6 times the third root of 18. Do I need to multiply 6 and 18 together? No, because as soon as I multiply them together, what am I going to do? Factor them again. So we'll just pretend that they're all the same number. What is 6 made up of? 2 times 3. What is 18 made up of? Not 3 3's. 3 times 3 times 2. Right? It's 2 and 9. And then the 9 turns into 3 3. So 3 3 2. What can I pull out? So I write a 3 on the outside. And 2 times 2 stays in. And we get a 4. Okay. What about the third root of 54 divided by the third root of, we'll say 2. Should I factor and then simplify, or simplify and then factor? We definitely want to simplify first. How come? The third root of 2 doesn't work. Right? There's nothing to pull out. Okay? So what is 54 divided by 2? So 54 divided by 2 is 27. So this is actually 2 times 27. I'm going to delete the 2's, and now I don't have a denominator anymore. Now I'm just left with the third root of 27, which is 3. One group of 3's. Okay? All right, let's do 288. Let's do the third root of 288 divided by, oh, what should we do here? The third root of 18. Let's hope this works. What should we do? 288 divided by 18, and we get 16. So this becomes 3 root 16. What is 16 made up of? 2, 2, 2, 2. Right? 4 2's. 2, 2, 2, 2. What do I pull out? One set of 2's with a 2 on the inside. Then you would need a group of 4. Yep. Yeah, that's a good point. Whatever number here is there, that's how many you need in each group. 5 in a group. Yep. Okay. 4.2. We are going to do 3 through 10 all, and then 13 through 16, all, and then 21 and 22. That's it. There are some with roots in the bottom that we don't want to do. They're not for this class. All right. Good luck.